The Organon, Aristotle's works on logic. Aristotle, who lived in the 4th century BC, is one of the greatest geniuses of all time. He wrote foundational works on physics, biology, metaphysics, ethics, rhetoric, politics, and the arts. And in each of these fields, his works count among the most influential ever written. For instance, his physics remained the dominant theory of the universe for 2000 years, until it was finally supplanted by Newton in the 17th century. Today, we'll study Aristotle's influential works on logic, the study of valid reasoning. In these works, Aristotle also invented science, which he correctly described as the only way to attain reliable knowledge of the world. When these works were finally rediscovered in the High Middle Ages, they helped create the academic atmosphere that would eventually give rise to the Enlightenment. But there is a problem. Aristotle's polished dialogues for the general public, which were really accessible, have been lost, and only his dry and technical lecture notes remain today. My job here is to make these works on logic accessible, which I think I managed to do in a way you can't find anywhere else on the web. So, let's start. Hey, good to see you. This is Stephan, author of In Search of the Sublime. On this World History channel, we'll trace humanity's relentless pursuit of scientific truth, moral excellence, and enlightenment. We'll meet anyone from Mesopotamian astronomers and Indian yogis to Greek philosophers and Enlightenment scientists. And you'll meet them firsthand using primary sources, giving you valuable insights that transcend the surface-level understanding you get on other channels. Go check it out for yourself. Let's start. The main purpose of these lectures is to give you an overview of Aristotle's main works on logic. These works were bundled after his death in a collection known as the Organon, meaning tool or instrument, referring to logic as the greatest tool of philosophers. The Organon now consists of 6 books. These books do not form an ordered whole. Instead, they were written and rewritten at different dates and were not made with an overarching plan. But historians have managed to roughly place them in chronological order. Let's quickly go through them to get an overview of these works. The oldest text seems to be Categories. This work is technically not even a work on logic. At this time, the field of logic had yet to form, but it was instead an attempt to group all the characteristics that things can have in the world. For instance, things can have a position, a color, and so on. We'll get into that later in more detail. This work was lost in the early Middle Ages, but reappeared in Western Europe in the 11th century, where it influenced many great thinkers of the time, as it presented a theory of the universe unlike any that had seen before. The second work is Topics, which is a guide on how to reason correctly in debates. Compared to his later works, this text is somewhat unorganized, but it still contains many good ideas. And this text, by the way, wasn't widely available in the Middle Ages until the 12th century. Then we have Sophistical Refutations, which was classified as a separate work by Aristotle's predecessors, but it originally was the final part of Topics. Where Topics deals with valid reasoning, Sophistical Refutations deals with logical fallacies known as sophisms. The text aims to protect debaters against people who use these tricks to win arguments. The fourth text is On Interpretation, which is one of his more important works on logic. Here Aristotle develops a more systematic understanding of logic. The main focus of this text is the study of contradiction, this again for the purpose of debate, where people often hold opposing views. And On Interpretation, by the way, was the only text from the Organon that was available throughout the Middle Ages. And now his 2 most important and most mature works. The text Prior Analytics gives the first systematic and comprehensive description of formal logic. It is a true milestone in world history. In this text, Aristotle describes and then studies the so-called syllogisms, which we'll learn much more about later in this lecture. And then finally, there was posterior analytics. This text used to be the final part of prior analytics, but later it came to be seen as a separate work. In this text, Aristotle studies how to apply syllogisms to the real world. He correctly concludes here that this requires the use of induction, which we'll talk about in depth, and which is to this day the basis of scientific thought. Like sophistical refutations and topics, both prior and posterior analytics were not available in the Middle Ages until the 12th century. The rediscovery of these works was deemed so important at the time that they received the term New Logic, Logica Nova, as opposed to the pre-12th century Old Logic, or Logica Vetus, which were based only on the text's categories and on interpretation. Interestingly, Aristotle was clearly aware that his study of formal logic was covering new ground. Nobody had studied formal logic before, it was a new field. In his sophistical refutation, for instance, he states that in his Rhetoric, which is another work on the arts of persuasion, he was working on a theory that was already partly worked out by others. Yet, he writes, of this inquiry of logic, on the other hand, it was not the case that part of the work had been thoroughly done before, while another part had not. Nothing existed at all, he says. And this makes it all the more impressive how far Aristotle got on his own in understanding logic on a formal basis. Before we dive into these texts one by one, let's first quickly discuss what was known about logic before Aristotle. Although Aristotle discovered formal logic, logic in the looser day-to-day sense of course existed since the beginning of man. Our capability to reason is indeed an innate part of our species. In fact, Aristotle himself defined humans as, quote, rational animals. Our ability to reason is one of our defining characteristics. It took time, however, for the rules of logic to become explicitly formulated. And although these explicit rules don't do much for us in our everyday life, it has become an indispensable tool in mathematics, philosophy, science, and lately also computer science. The first explicit logic likely developed in the field of geometry. Geometry, meaning land measurement, was originally an empirical science, used to find distances and then also surfaces and volumes. At first, these rules were found mostly through trial and error. Measure the diameter of the circle and its circumference, and you'll see they differ by a factor of around 3, which is an estimate of pi, for instance. Yet in time, starting with Thales and Pythagoras, mathematics and geometry slowly turned into an a priori science, meaning a science established solely on self-evident propositions, which are known as axioms, and then the logical inferences based on these axioms. Let's now discuss a sophisticated early application of logic, which developed in this mathematical scene. To show that a statement is false, we can either show that it is false directly, or we can assume the statement to be true for a moment, and then show that absurd consequences follow from it. In that case, you also know that the original statement must be false. When Aristotle discusses this technique, he names Pythagoras' proof that the square root of 2 cannot be written as a over b, where a and b are whole numbers. It is what we now call an irrational number. You can find the detailed proof in my book, which you can find for free on worldhistorybook.com, but the main technique to solve this I'll show right now. Pythagoras first assumed that both a and b are whole numbers, which is not in fact the case, but he just assumed it for a moment, and then he shows through a number of steps that I won't go into here, that b must be both even and odd at the same time, which is impossible, and therefore we must conclude that a and b are not whole numbers, thereby proving that the square root of 2 cannot be written as a over b. It is a very impressive way of reasoning. The philosopher Plato who was the teacher of Aristotle, famously added some explicit logic in many of his dialogues. Plato used what would later be called syllogisms. Before making his case, he would first ask his students to confirm that arguments of a certain abstract form were valid. For instance, he said, "All philosophers are vague, and Plato is a philosopher. Therefore, Plato must be vague." This is an example of a syllogism. It takes two premises, namely, all philosophers are vague, and Plato is a philosopher, and combines them to form a new conclusion based on logic, namely, that Plato must be vague. If both premises are true, which is not necessarily the case, but if they are true, then the conclusion must also be true. Plato also observed that for a sentence to classify as either true or false, it needs to at least have both a noun and a verb. For instance, it is nonsensical to speak of the sentence, "the cow," as either true or false, but "the cow eats" can be true or false. Aristotle would later agree with this. Plato also spent a lot of time trying to find correct definitions. Today, we often see definitions, like from the dictionary, as arbitrary labels to things. We might call a bird with certain characteristics a magpie, but we might just as easily have called it something else. Plato and Aristotle instead saw definitions as referring to real things, and this will be important as we shall see in Aristotle's description of science. For Plato and Aristotle, for example, the definition of a circle, for instance, is the set of points at equal distance from a given point, which in fact creates a circle. This type of definition gives us the essence of what a circle is. And that was the purpose of definitions for the Greeks. To find these definitions, Plato recommended the method of division. The trick here is to start with a very general concept and then to make it more and more specific until the concept is finally uniquely described. Let's go through an example. For instance, Socrates defined an angler as a technician, very broad, who practices the art of the acquisitive coercive sort through hunting of living things that swim in the water by striking them with a hook. And that is the method of division. Finally, we have to mention the sophists, who actively studied logic to win arguments, famously also through deception. And as you can imagine, this was especially popular among lawyers. Socrates famously resisted this practice. He believed that people should speak truth and not play word games. Plato, by the way, described two of these sophists in one of his dialogues, who used these tricks to demonstrate absurd opinions. They demonstrated, for instance, that the father of Ctesippus was a dog, since he had a dog who was a father since he had puppies. And the dog was also his, like his property. And if you combine these premises, you find that the dog must be his father. Of course, this is just a funny wordplay, a deliberately mistaken version of a syllogism. So, in conclusion, before Aristotle, a lot of logic was done in Greece, but nothing systematic. Now, we go through Aristotle's texts one by one. Let's start with his oldest text on logic, the Categories. The main purpose of categories is to list all types of subjects and predicates that exist in the world. Well, first, what are subjects and predicates again? A subject is what a sentence is about. In the sentence, "the dog is running," for instance, the subject is the dog. The sentence is about the dog. And a predicate is a property that a subject has or is categorized by. For instance, in the sentence, "the dog is running," running is the predicate. It is a property of the dog. In his text, Aristotle recognized 10 categories. These 10 specific categories are not very influential to this day, so I'll go through them quickly. He wrote, examples of substance, a first category, are man, horse, so they're objects. Of quantity are 4 foot, 5 foot. Of qualification are white, grammatical, of relative are double, half, larger, of where are in the lyceum, in the marketplace, of when are yesterday, last year, of being in a position is lying down, is sitting, of having is has shoes on, has his armor on, of doing is cutting or burning, of being affected is being cut or being burned. And those are his 10 categories. In this text, Aristotle does make the important distinction between what he would later call the essence and the accident. For instance, an apple is fruit tells us something essential about the apple that cannot have been otherwise. All apples are fruit. It is the essence of an apple to be a fruit. And now compare this to an apple is green. This is accidental, because an apple can be otherwise. It might be red, for instance. In the terminology of the categories, he describes this difference as the difference of what is said of an apple and what is in an apple. What is said of an apple is its essence, that it is a fruit, for instance. And what is in the apple, its greenness, is what is accidental about it. Now, you can probably already see why his later concepts are more useful, because it is somewhat strange to say that the apple's greenness is in the apple. But that's what he did at this stage of his development. Aristotle also noticed that what is accidental of a thing, or what is in the thing, cannot exist without that thing. For instance, the green of an apple cannot exist without the apple. And he then added that an apple is a substance, a thing, and what is in the apple, for instance, its greenness, is a non-substance, from which he concluded that what is accidental about the apple is non-substance. He then makes the important distinction between particular and universal predicates, but again without using these precise words yet. Instead, he called them primary and secondary substances. A horse as a species of animal is an example of a secondary or universal substance. And one particular individual horse is an example of a primary or particular substance. Aristotle then connected these universal statements to the essential or said of category. What is said of, or what is the essence of a bunch of individual horses, is that they belong to the species horse, which is universal. And what is said of an apple is that it is a fruit, which is true for all apples. It is a universal claim. Aristotle then went on to conclude that primary or particular substances are the most fundamental. And this is in fact a really important conclusion. Without individual apples or individual horses, there can be no secondary or universal substances. Without individual apples, you don't have the fruit apple. Without individual horses, you don't have the species horse. And also, without particular or primary substances, there can also exist no non-substances. If there were no things in the universe, there also could not be any non-substances that are in these things. For instance, if there are no objects, there can also not be the color green, because the greenness is in the object. Now, let me tell you why this is such an important decision. This theory, namely, makes a clear break with his teacher Plato. Plato believed that the most fundamental things are the so-called forms or ideas, which he described as heavenly blueprints of things. For instance, he believed that all tables that we see around us are based on the form table that had an independent existence in a sort of heavenly realm. And it was true of everything. The individual rivers that we see are all based on the form of river that exists in heaven. So for Plato, and this is the case for many religious thinkers, we start out with the general concepts, the forms, and then we assume that from those forms the individual objects are created that we see in the world. But Aristotle said the opposite. For him, only primary substances have an independent existence. In reality, there only are individual apples. And the universal concept of apple only exists in our mind after repeated exposure to apples. But these concepts do not have an independent existence. As you shall see near the end of this lecture, this conception will eventually lead to the origin of science. And by the way, it is also what we see here in the famous painting The School of Athens by Raphael. Here in the middle, we see Plato on the left pointing upwards to the forms, to the abstract universal concept as the basis of the universe, while Aristotle on the right is pointing downward to the earth, to the individual particular substances that we actually know do exist. Now, let's move on to Aristotle's second text, the Topics. Topics is a guidebook to help debaters make valid arguments. In this text, he calls it a work on dialectical reasoning, which he defines as reasoning which proceeds from opinions that are generally accepted. That is to say, it is about everyday debate. He then contrasts this with demonstrative reasoning, which produces certain and necessary conclusions, such as is the case in mathematics. You can prove that 5 plus 5 is 10 with absolute certainty. As opposed to his later prior analytics, Topics is not a well-ordered text on reasoning. Instead, it can be seen as the first attempt to bring some order out of chaos in this new field. Let's start with what a topic actually is. Aristotle defined a topic as a recurring logical pattern in debate. For example, Aristotle notes that, quote, if an attribute belongs to all of a kind, we shall have proved that it belongs to some of that kind. For example, if we know that all ravens are black, then the first, say, 5 ravens you will encounter will necessarily be black. If you know that all are black, then some must be black as well. Aristotle also says, for instance, that if a number of propositions jointly entail a conclusion, then if the conclusion turns out to be false, then at least one of the premises must also be false. And another example, if you want to definitively reject a statement, such as some pleasure is good, it would have to be shown universally that none is. For only if you know that no type of pleasure is good, can you reject the claim that some pleasure is good. And here you can already see his systematic way of reasoning. He continues, likewise, if he said that some pleasure was not good, it would have to be shown universally that all is good. It is not possible to refute that statement in any other way. And if we want to refute that some pleasure is good, but not others, we'll have to show, quote, that all pleasure is good or that none is. And if we want to refute that only one pleasure is good, we have to show that all or that none or that more than one is good. And of course, you might need to pause for a second to verify that this type of reasoning is in fact correct. And finally, if the thesis is even more determinant, as for example that practical wisdom alone among the virtue is knowledge, it can be refuted in 4 ways. For if it were shown that all virtue is knowledge, or that none is, or that some other, for instance justice, is, or that practical wisdom itself is not knowledge, then what is laid down would be refuted. A very precise way of reasoning. In Topics, Aristotle also recognizes 4 ways in which a predicate can be related to a subject, and these are now called predicables. His first example is definition, in which case the predicate describes the essence of a subject, what makes a certain thing a thing. There are also properties which he sees as necessary but less essential. For instance, according to Aristotle, man is in essence a rational animal, that's a definition. But man is also capable of, say, learning grammar, which is less essential and therefore does not belong in the definition category, but it is a property of a subject. He then remarks that these 2 concepts, definition and property, are convertible. For instance, all men are rational animals, a definition, implies also that all rational animals are men. You can flip the predicate and the subject, And you can do the same for all men have the capacity to learn grammar, since this implies that all those with the capacity to learn grammar are also men. The third predicable is genus, or the larger kind to which a species belongs. And we have the accident, which belongs to some instances of a species but not to all of them. And these two are not convertible. For instance, a horse is an animal, which is a genus, does not imply that an animal must also always be a horse. And an apple can be green, that is an accident, but a green thing is not always necessarily an apple. Aristotle then uses these four predicables when reasoning. For instance, he says, if the good is made the genus of pleasure, consider whether there is any pleasure which is not good. For if there is, it is clear that good is not the genus of pleasure. Now, all these examples are very clever, but topics doesn't yet have the same generality and also the simplicity that his later work Prior Analytics will have. And at this point he also does not yet use letters for variables, such as all A are B, in which you can fill in for A and B whatever word you want. For instance, all men are mortal. Now we move to the text Sophistical Refutations, which used to be attached to the end of Topics. Let's discuss it now. Whereas Topics is about valid reasoning, Sophistical Refutations is about reasoning that seems valid but is not. The purpose of this text is to teach debaters not to get tricked by these sophisms. He recognized 13 fallacies in total, and I'll go through them quickly. The first is equivocation, which refers to using a different meaning of a word in the premise and in the conclusion, thereby making the conclusion invalid. A modern example of this fallacy is, only man is rational, here using man with the meaning human. And also, no woman is a man, here meaning a male with the word man. From this we can falsely conclude that therefore no woman is rational. Here we've used two meanings of the word man in order to convince the audience of a wrong conclusion. Then we have an amphiboly, which arises through grammatical ambiguity. A modern example is this: John saw James with a telescope. Does that mean that John had a telescope and was looking at James? Or did John see James holding a telescope? It is unclear in this sentence. Aristotle then concluded that both of these ambiguities undermine the principle that words in debate should be unambiguously defined. Then we have composition, which means inaccurately applying a characteristic of a part to the whole. For instance, if you can lift one brick, it does not mean that you can lift a whole house made of bricks. And then we have division, which is the opposite. If you can live in a house of bricks, it doesn't mean you can live in one brick. Then we have prosody, referring to ambiguity arising from words that change their meaning with different accents. In Greek, you have a word that can mean where in one case and not in another, depending on the context. Then we have figure of speech, which is about confusing the metaphorical and literal meaning of a phrase. We also have the fallacy of accident, involving applying a rule of thumb to a situation where it does not apply. For instance, if you agree that cutting people is a crime, then it follows that surgeons must be criminals, which is of course nonsensical. The rule of thumb is applied here in the wrong way. Then we have secundum quid, which refers to using facts that apply exclusively to exceptional cases and then use that to create generalizations where it doesn't apply. For instance, it is false to conclude that all musicians die young, based on a few famous cases of musicians dying young. Then we have the irrelevant conclusion fallacy, which describes an argument that although it might be factually accurate, it is not relevant to the point. An example is someone asking if something is allowed by law, and then the person answers that it should be allowed, which is not the point of the conversation. And then we have the begging the question fallacy, which uses circular reasoning to make a point. A modern example is to say that the Bible is true because it is the Word of God, and that the proof for this is that it is stated in the Bible. It is circular reasoning, and therefore invalid. Then there is the false cause fallacy. An example of this is, the moon is more often visible at night, therefore the moon causes nightfall. Correlation is here confused for causation. The fallacy of affirming the consequent refers to where causation is not reversible, because the case is true only under certain circumstances. For instance, one can correctly reason, the lamp is broken, so now the room is dark. But it isn't necessarily true, therefore, that if a room is dark, that must mean that there must be a broken lamp. There can be many other reasons for the room to be dark. And finally, we have the fallacy of many questions, which involves asking a question that contains an unproven presupposition. For instance, I might ask, is Mary wearing a blue or a red dress? Thereby presuming she is wearing either a blue or a red dress, which might not be the case. Now, let's move on to one of his more important texts, Uninterpretation. The main purpose of uninterpretation is to determine pairs of statements that are each other's contradictions. For this, he first distinguished between universal statements, such as all x are y, and particular statements, such as some x are y. And also between affirmative statements, such as x are y, and negative statements, such as x are not y. Although at this point he did not use those letters as variables. These distinctions then give us a fourfold classification, which medieval logicians would call A, E, I, and O statements. A universal affirmative statement, such as all x are y, was called an A statement. A universal negative statement, such as no x are y, was called an E statement. A particular affirmative statement, such as some x are y, was an I statement, and a particular negative, such as some x are not y, was an O statement. Aristotle then set out to find relationship between these statements. Since the Middle Ages, these relationships are usually summarized by a diagram known as the square of opposition, which remains a useful tool to this day. Let's now go through it step by step. In the four corners, we have those four statements, all x are y, no x are y, some x are y, and some x are not y. The two statements on the top, Aristotle called each other contraries. He concluded that they cannot both be true, but they may both be false. For instance, if all ravens are black, then it cannot be true that no ravens are black. But they can both be false. All apples are green is not true, and no apples are green is also not true. The two statements at the bottom, Aristotle called subcontraries. And in this case, they can't both be false, but they may both be true. And also, if the statements above are true, then it must also be true that the statements below them are true. These are called each other's subalternates. And finally, the contradictories in the middle. Two statements on one of the diagonals can both be true, and they cannot both be false. For instance, if all ravens are black, then it cannot be true that some ravens are not black. And this is how all these statements are logically related. And here, by the way, we see this square of opposition in a 16th century text. Now, there is one more thing in uninterpretation that is interesting to discuss. In the text, Aristotle also implicitly discusses the so-called law of excluded middle. He defined this law more explicitly in his work Metaphysics. He wrote, "It is necessary in every case either to affirm or to deny, and that it is impossible simultaneously to be and not to be." Said differently, a statement is either true or untrue. There is no third option. Now let's see how he applied this here. In Uninterpretation, he discusses how this law applies to events in the future. He says that either there will be a naval battle tomorrow, or there will not be a naval battle tomorrow, which is in line with the law of the excluded middle. But at the same time, we cannot be sure which one is true at this particular moment, because the future hasn't happened yet. Otherwise, the future would be fully determined if we could know for sure. He writes, I say, for example, that it is necessary that either there will be a sea battle tomorrow, or there will not be a sea battle tomorrow. But it is neither necessary that a sea battle will occur tomorrow, nor that it will not occur. Rather, it is necessary that it will occur or not. Unfortunately, Aristotle doesn't go deeper into this, but Aristotle seems to deny determinism here. And it is telling that the later Stoics, who were in fact determinists, who believed that everything follows from cause and effect, did not agree with Aristotle on this point. And Epicurus, who believed in a precursor of free will, actually agreed with Aristotle. For free will seems to imply that not everything is fixed in the future. Now, we move to Aristotle's most important text on logic, his Prior Analytics. Prior Analytics is a systematic study of drawing valid conclusions that follow from given premises. Take for instance the sentence, all ravens are black. If we regard this statement as true, then we can infer with absolute certainty that the following statement must also be true. There are no white ravens. If all ravens are black is true, then it must also be true that there are no white ravens. And this is an example of using logic to find valid conclusions. It is also called deduction. Aristotle wrote about this. A deduction, or in Greek syllogismos, is an argument in which certain things having been supposed or presumed, something other than what was laid down, results by necessity because these things are so. Let's unpack this sentence for a moment. The things supposed are the premises of the argument. It is what is assumed beforehand. For instance, in the previous example, that all ravens are black. While that what results by necessity are the conclusions in the last examples that there are no white ravens. Now with this information, let's go to this brilliant definition one more time. A deduction is an argument in which certain things having been supposed, something other than what was laid down, results by necessity because these things are so, because it is logical. Interestingly, Prior Analytics is the first work in history where letters are used as general variables, as in all x are y, where you can fill in a word of your own choosing for x and y. For instance, all men are mortal. The use of letters as variables in algebra did not occur until Diophantus in the 3rd century AD, which is 600 years later. In this text, Aristotle starts with his 4 types of statements which we introduced in On Interpretation, and which are known as categorical presuppositions. We'll repeat them here. We have the universal affirmative, all x are y, which are called A statements. We have the universal negative, no x are y, which are called E statements. We have the particular affirmative, some x are y, which are called I statements. And we have the particular negative, some x are not y, which are called O statements. And I've summarized this here on the left for quick reference. In each of these presuppositions, such as all x are y, the x is called the subject of the sentence and the y is called the predicate. And as a reminder, a subject is what the sentence is about, and a predicate is a property of that subject. For example, in the sentence, all ravens are black, the ravens are the subject, and black is a property of those ravens. Aristotle then showed how to combine 2 of these statements to find new conclusions. And these constructions, with 2 premises and 1 conclusion, are now called syllogisms, after the word that Aristotle actually used for deduction, syllogismos. Let's study an example. All x are y, and all z are x. Those are the 2 premises. Therefore, that's the conclusion, all z are y. Now, this might be very abstract, so let's put in some words for x, y, and z, and then you can easily check that this is logically consistent. A famous example is, all Greeks are mortal, if we assume that to be true, and all Athenians are Greek, if we also assume that to be true, then we can conclude that all Athenians must be mortal. This has the same structure as the more abstract syllogism above. Here are two more difficult cases. I'll read them and you can fill in words for yourself and check whether it is correct. All x are y, and some z are x, therefore some z are y. And no x are y, and all z are x, therefore no z are y. Feel free to pause for a moment and fill in some words. Whatever words you choose for x, y, and z, if the premises are correct, you'll also automatically get a correct conclusion. Now, with these two premises and one conclusion, and with four categorical presuppositions, those A, E, I, and O statements, we get a total of 4 to the third is 64 combinations, which medieval logicians would call moods or modus, meaning ways. And you can see all of these 64 combinations below. Aristotle then set out to check which of these 64 syllogisms are in fact correct. Here, for instance, is his own first example. He writes, if A is predicated of all B, and B is predicated of all gamma, then it is necessary that all A should be predicated on all gamma. Because in this case, both the premises and the conclusions are A statements, namely of the form all x are y, this mood can be summarized as AAA. Now, to make things even more complicated, all these 64 combinations can also appear in 4 variations called figures. In the table below, we see the 4 figures for only the case AAA. Let's take some time to study this table. Let's start with the conclusion, which is the same in all figures. It is written as all S are P in all cases. S here is the subject of the conclusion, and P here is the predicate of the conclusion. Now we look at the two premises. We have the major premise and the minor premise. The major premise is defined as the premise that contains the predicate of the conclusion. And as you can see, this is why in all figures the major premise has the letter P in it. And the minor premise is defined as the premise that contains the subject of the conclusion, the S. And that is why you can see an S in all figures of the minor premise. The trick with these syllogisms is to include a middle term, M, that connects those two premises and thereby allows for a conclusion. For instance, all Greeks are mortal and all Athenians are Greek, therefore all Athenians are mortal. The subject of the conclusion here is Athenians, which is shown in blue here. And this also occurs in the minor premise. And the predicate of the conclusion is mortal, which is here shown in green, and this appears in the major premise. And then we have that middle term, Greek, here shown in yellow, that connects the two premises and allows for the conclusion that connects Athenians to mortals. Aristotle, by the way, only recognized the first 3 figures. The 4th figure was recognized by his student and successor at the Lyceum, his school, named Theophrastus. Of all these 64 moods and those 4 figures, giving us a total of 256 combinations, Aristotle only found 14 valid moods. And in the Middle Ages, logicians added some consonants to make it easier to remember these valid moods. For instance, the first valid mood of figure 1 is AAA, which the medieval logicians turned into Barbara. And here we see the 4 valid moods of the first figure, summarized as Barbara, Celerant, Dari, and Ferio. Aristotle regarded these first figure moods as perfect and self-evident, requiring no further arguments. Especially if you fill in words for the M, the S, and the P, it is all self-evident why these syllogisms are true. He then studied to see if there were some patterns in these valid moods of figure 1. He, for instance, found that the conclusions include all 4 kinds of statements. Let's go back for a moment. We see that the conclusion of Barbara is all SRP, of Celerant is no SRP, of Dari is some SRP, and of Ferrio is some S or not P, so all those 4 propositions are included. Also notice that all the major premises are universal, either all or no, and that the minor premises are all affirmative. The valid second figure moods are Cesar, Camestres, Festino, and Barocco. And in this case, and you can check it for yourself if you want, you have to write it out, all conclusions are negative, the major premises are all universal, and one of the premises is always negative. And the valid third figure moods are Darapti, Velapton, Dissamis, Datisi, and Boccardo. And here all the conclusions are particular, and the minor premise is always affirmative. Aristotle also recognized some rules that are applicable to all valid moods. He found that at least one premise must always be universal, and at least one must be affirmative. And Aristotle's successors, by the way, would take this to the next level by finding general rules from which to derive the entire theory. But that goes beyond what we can do right here in this lecture today. Next, Aristotle set out to reduce the second and third figure back to the first figure, meaning that he showed that the second and third figure follow from the first figure mood. They can be derived from them. As we shall see, he does this using an operation called conversion, which amounts to swapping the subject and the predicate terms. This method is only valid for the statement no x are y, for if no x are y, then no y are x, and some x are y, for if some x are y, then some y are also x. For instance, if some sheep are animal, then some animals are also sheep. Now let's apply this to reduce Camestres, a valid mood from figure 2, to Celerant from figure 1. Let's first read Camestres. It reads, if all A are B, and if no C are B, then no C are A. Now we use that method of conversion to the second premise and to the conclusion. No C are B becomes no B are C, and no C are A becomes no A are C. Now, the only thing we need to do is swap the 2 premises, which you can always do. It doesn't matter in what order you read the premises for the conclusion. And if you do that, we end up at if no B are C and if all A are B, then no A are C. And this is an EAE statement. It is Celerant from figure 1. So we have now shown that Camestres from figure 2 follows logically from Celerant from figure 1. Very impressive way of reasoning. In some cases, Aristotle also had to use a method called reduction to the impossible. Here we take a conclusion of a valid mood and then take its contradictory, its opposite. And he then shows that this leads to a contradiction in the original premises, showing that the original mood must in fact be correct. Because if the contradictory of the conclusion is wrong, then the original statement must be correct. Let's apply this here to Barocco from figure 2. It reads, if all A are B and if some C are not B, then some C are not A. What we now do is we assume the contradictory of the conclusion and we then combine it with the first premise to see where that leads us. The original conclusion was some C are not A. The contradictory of this is all C are A. For if some C are not A is incorrect, then all C must be A. And we combine this with the first premise of Barocco, which is all A are B. Now this combination, if all A are B and all C are A, is actually equal to Barbara from figure 1. And Barbara from figure 1 then gives the conclusion all C are B. So we end up with if all A are B and all C are A, then all C are B. But all C are B, the conclusion from Barbara, contradicts with the premise from Barocco that some C are B. From this we conclude that the assumption all C are A must be false, so that the original statement is contradictory, some C are not A, must in fact be correct. And in this way we have used Barbara to prove that Barocco must in fact be correct. So in other words, we have reduced Barocco to Barbara. In this way, Aristotle managed to show that all valid moods can be reduced to the first two figures of figure 1. Even the other two valid moods of figure 1, he showed, can be reduced to those first two moods of figure 1. For instance, he showed that Dari of figure 1 could first be reduced to Chemestris from figure 2 and then to Celerant from figure 1. And let's show this one last example. Dari figure 1 reads, if all A are B and if some C are A, then some C are B. We again use that contradictory method. If we assume the contradictory of the conclusion, we get no C are B. Because if some C are B is not true, then no C are B. We then combine this with the original first premise, all A are B. So we get if all A are B and no C are B. Well, this is actually the same as Chemestris figure 2, which concludes that no C are A. But no C are A is in direct contradiction with the second premise of Dari, which says that some C are A. If no C are A, it cannot be true that some C are A. And therefore we must conclude that our assumption that no C are B must be false, and that the original, it's contradictory, some C are B must in fact be correct, thereby proving Dari figure 1 can be reduced to Chemestris figure 2. So now we have reduced Dari figure 1 to Chemestris figure 2, and earlier in this lecture we have shown how to reduce Chemestris figure 2 to Celerant figure 1. And in this way everything can be reduced to the two valid moods of figure 1. Very impressive reasoning. Now, if we would add another method called obversion, which Aristotle did not know of, then all the valid moods can in fact be reduced to only Barbara. So what is obversion? It amounts to changing the predicate into its contradictory and then turning it from an affirmative to a negative statement and vice versa. And this method, it turns out, works for all four of the categorical presuppositions. It turns all x are y into no x are non-y. It turns no x are y into all x are non-y. It turns some x are y into some x are not non-y. And it turns some x are not y into some x are non-y. And with this method, all valid moods can be reduced to Barbara number 1. But it is beyond the scope of this lecture to show this right now. Now, as I said before, Aristotle only studied the first 3 figures. His student Theophrastus included the last 4th figure and found another 5 valid moods there, giving us a total of 14, which Aristotle found, plus 5 is 19 valid moods. Nowadays, we also add 5 so-called weakened moods, which are technically correct, but they have a stronger possible conclusion, such as all x are y and all y are z, therefore some x are z. Aristotle did not consider this syllogism valid because there is a stronger conclusion, namely all x are y and all y are z, therefore all x are z. But still they're technically correct. And so this gives us a total of 19 plus 5 is 25 valid moods, of a total of 256 combinations. Finally, Aristotle also discusses so-called modal statements in his prior analytics, which contain premises with the words necessary and possibly. Aristotle takes some initial steps here, but the theory isn't properly worked out here yet. That would happen in future generations. So I'll skip this topic for now. And now the final text of the Organon, the Posterior Analytics. This text holds a special place because it introduces scientific thought. making it one of the most important texts in world history. The goal of posterior analytics is to connect syllogisms to the real world. The problem with syllogisms, namely, is that they tell us nothing directly about the world. The conclusions of a syllogism are only true if the premises are also true, which isn't necessarily the case. In case that we do know that the premises are true about the world, Aristotle says that syllogisms in that case become productive of scientific knowledge. And if we find knowledge in this way, Aristotle speaks of a demonstration, in contrast to syllogisms based on unsure premises, which he calls dialectical. The goal of posterior analytics became finding these true premises, which he calls the first principles, or archai, on which to base a science. He did agree that these first principles cannot be proven syllogistically. As a result, Aristotle calls them indemonstrable. And he concluded that there was no way around this. We have to start any scientific theory on some premises from which we continue to reason. And they cannot be proven themselves syllogistically. For any science, Aristotle concluded, we need some first principles, some premises to start with, since otherwise we either end up with infinitely long explanations, where every conclusion follows from another premise, which is of course impossible, or we get circular reasoning, which is logically invalid, or we become skeptical about whether things can be known at all, which to Aristotle was also unacceptable. The Greeks tend to assume as an axiom that our brain must be capable in some way, through reason, to understand the universe. Aristotle then proceeds to discuss what makes a syllogism a demonstration. To demonstrate something, according to Aristotle, is to explain why something is the case. And as it turns out, not every syllogism has this explanatory power, even if the reasoning in the syllogism might be valid. Let's for instance take Aristotle's own example. The next syllogism is valid and it also is explanatory. It states every planet is near, meaning way nearer than the stars. And everything near is a non-twinkler, which refers to the fact that planets don't twinkle but stars do. Therefore, he concluded that every planet is a non-twinkler. Crucially, the middle term near here provides the why. It explains why the planets don't twinkle. Because the planet is near, it doesn't twinkle. We can then contrast this with the next statement, which is also logically valid, but it does not explain. Every planet is a non-twinkler, true, and every non-twinkler is near, true. Therefore, every planet is near, also true. This does prove that the planets are near based on these premises, but non-twinkling is not the cause of the planet being near. It's the opposite. It is because the planet is near to us that it doesn't twinkle. Aristotle also gives the following valid syllogism that does not explain. He writes, everything that breathes is an animal, and no wall is an animal, therefore no wall breathes. This, Aristotle said, does not explain, it does not have explanatory power, because the middle term here, animal, is too wide of a concept. Since not all animals breathe. This syllogism would be explanatory, by the way, if we would turn the first statement into everything that breathes has lungs. And then we continue, and since no walls have lungs, therefore no walls can breathe. This actually explains why walls cannot breathe, because they have no lungs, not because they are not an animal. Now, let's return to the first principles. Aristotle identifies them with definitions. The premises to him are definitions. Whereas today we often believe that definitions are just arbitrary labels for things, Aristotle believed that definitions point to something real, to the essence of a thing, to what it is, which medieval philosophers would call quiddity. But what does it mean to know something's essence, its quiddity? Aristotle said that a property that belongs to something's essence must be a necessary part of it. It cannot exist without it. For instance, an apple is necessarily a fruit. Yet there are also properties that necessarily belong to something, but that are not essential. For instance, man, defined by Aristotle, is a rational animal by definition. But it is, for example, also capable of grammar. But this is less fundamental, since the rationality can explain the grammatical capacity. Therefore, the rationality is more explanatorily basic. Definitions, Aristotle added, should also be more than just a word for a familiar observation, which is now called a nominal definition. For instance, we might name a familiar loud sound as thunder, but then we still need to describe the cause of this noise. And according to Aristotle, at least his theory at the time, this was caused by the extinguishing of fire in the clouds. This definition answers what thunder actually is, its essence, and it can then also explain the noise. We can reason that the extinguishing of fire in the clouds, whatever that might mean, causes the sound. That nominal definition, that familiar sound, now follows deductively from his actual definition, which has its essence in it. Strangely, from a modern perspective, Aristotle also claims that definitions are necessarily true. But how can this be? Science is empirical, which makes it always uncertain to some extent. This, of course, is true, but Aristotle just had another definition of definition. In a way, it is fair to assume that there are necessary truths out there, although we can never be sure that our definitions are exactly correct. And Aristotle's definitions refer to these truths out there in the world. Now, how are these definitions found in practice? This is discussed in a notoriously difficult final chapter of the Posterior Analytics. It is very difficult to read, but you know me by now, I'll make sure that you'll understand it. In this chapter, Aristotle claims that definitions are not demonstrative, as we've already discussed, because they are the first principles on which to base your theory. They are also not innate, that is, we aren't born with them. And they're also not self-evident, since we are ignorant of a lot of them. Anticipating the scientific revolution that occurred 2 millennia after his death, Aristotle concluded from this that all knowledge instead has to enter the mind through the senses. He wrote, "We conclude that knowledge is neither innate nor developed from other higher states of knowledge, but only from sense perception." And in the Middle Ages, St. Thomas Aquinas summarized this position very concisely. Nothing is in the intellect that was not first in the senses. And John Locke would later say the same thing in the 17th century. More precisely, Aristotle concluded that the only thing we can do to find these premises is to perform a finite number of individual observations. And for observation, he used the word peperamonoi in Greek. And from those finite number of observations, we can, if we are lucky, grasp what is universal in all of these observations, which allows us to make generalizations. Aristotle called this process induction, which he defined as, quote, an argument from the particular, from individual observations, to the universal, to a generalization. And that is a very scientific way of looking at the world. Let's take a practical example. We might perceive a swan that is white. After seeing a number of them, we'll eventually remember that it is white. This process is repeated for many swans until we grasp at some point that all swans we have ever seen are in fact white. And at that point we understand, or intuit, the Greek word here is nous, that all swans are white. That is the generalization. But since this conclusion is based on a finite number of observations, we can never be sure of this. And in fact, eventually black swans were found in Australia. And this is why those premises of a scientific theory cannot be considered demonstrations, since they are not certain knowledge. Although, of course, measuring thousands of swans and finding them all to be white does say something about the world. Now, if we then collect a bunch of these definitions based on a lot of measurement, we can then use them as first principles or axioms to explain the observable world deductively through syllogistic logic. And that is quite a close approximation of how science works to this day. And notice, by the way, that Aristotle's method of induction based on individual observations is in stark contrast to the usual Greek theories, including the theory of forms of his master Plato. For Plato, as you might remember, universals truly existed in a heavenly realm and were to him in some sense more real than the imperfect earthly particulars. For instance, there was the ultimate form of a horse, for instance, that existed in a heavenly realm, according to Plato, and that was the basis or the blueprint of the individual horses that we see around us here. Also, to find definitions, Plato used his method of division, which we discussed, which entailed starting with the most abstract category and then working downward to pinpoint the definition specifically. Aristotle instead worked upward, starting with individual observation of particulars in the world, and then slowly collecting enough information to create universal concepts, which according to Aristotle do not have an independent existence in some heavenly realm. They only exist in the mind. And this idea is called empiricism, and it is the basis of scientific thought. And there we have it, a lucid explanation, as far as that is possible, of Aristotle's great works on logic, called the Organon. Thank you so much for listening. If you want to know more about Aristotle's theories or any other topic from world history, read my book In Search of the Sublime. You can buy it on Amazon or you can read it completely for free on worldhistorybook.com. See you next time.